Okay, thanks for bearing with us. We're still working through this, but I don't want to keep you waiting any longer. Thanks for joining today. My name is Cole Kopka. I'm the Assistant Director of PacTrans. Today's webinar is some collaborative work between us, the U.S. Department of Transportation, Yakima Nation, and the CSET Tier 1 University Transportation Center. The title of today's webinar is USDOT Safety Data Initiative, Comprehensive Roadway Safety Data Visualization and Evaluation Platform for Yakima Nation. Before I introduce today's presenters, let me just really quickly give you a few notes. So first off, with Zoom today, the two ways that you can interact with us as a participant is either through the Q&A box, which you'll find an icon at the bottom of your screen for. Should you have questions throughout today's presentation, please just click that icon. You can input a question there. You can see other people's questions there. You can upvote questions you like. And after our group is done presenting today, we'll have some time for some Q&A and discussion. And then there's also should be a chat icon at the bottom of your screen. If you're having any technical difficulties or need to communicate with any of the panelists directly, you can use the chat feature. But again, we would ask that you direct your questions to the Q&A panel, not the chat box. The other quick note I wanted to make is that this webinar is being recorded, and probably in the next day or two, we will get this posted to our YouTube channel, and on our website, it'll go out on our monthly e-newsletter, so that if you or anybody else ends up missing any portion of it and you want to revisit it, we will have a record of it there. Okay, so without further ado, I would like to introduce today's presenters. Our first presenter is Hollyanna Littlebull. She is the Tribal Traffic Safety Coordinator for Yakima Nation's Department of Natural Resources Engineering Program. Our second presenter is Dr. Wei Soon. He is a research associate in civil and environmental engineering at the University of Washington. And our third presenter is Sam Ricord. He is a graduate research assistant in the civil and environmental engineering department at the University of Washington. So with that, I'm going to mute myself and let these fine folks take it away, and I'll be back to join once their presentation's over and we move to the Q&A and discussion time.
Thank you, Cole. Hello, my name is Hollyanna Littlebull. I am the Tribal Traffic Safety Coordinator for Yakima Nation. I come from 30 plus years of public safety experience. I've been a police officer, a paramedic, a fire rescue, and I've also been an educator in many different fields. And so I have a unique perspective of coming into the 4 E's, which they consider the strongest links for tribal traffic safety and national traffic safety. And so if we can go into the next slide, please. So one of the challenges that we have in Indian country is that not only are the roads federal, they're also state, they're also county, they're sometimes city. And so we have a lot of different jurisdictions that involve the population of reservations. And so one of the things that we were noticing was that they are 2.5 times more than urban areas for fatalities. And in Yakima County, we have the highest number of fatalities. Next slide, please. So because we have the highest number of fatalities for traffic crashes and pedestrian fatalities, one of the things we had to look at was what is some of the issues and what are some of the challenges that we face in Indian country, and that is being able to have multimodal transitions from going from one place to another and getting from point A to point B. Next slide. So one of the things that we have seen is that not only do we have the highest number of fatalities, but also we have per population, which when you're looking at per population and you're not looking at just jurisdiction wise, it means that you have the highest number of fatalities according to population for the state. And according to this ratio, we have the highest number of fatalities in Washington state for pedestrian fatalities. Next slide. When we started to map these issues and where these fatalities were happening, we were seeing that Toppenish City, which is not labeled here, but you can see all the dots around the area. That is the epicenter for pedestrian fatalities. One of the issues that we also have is transition between one place to another. Go ahead, next slide. So one of the things that we started seeing was that in our road conditions and by engineering standards, according to federal regulations, there were no shoulders that were existent. We had agricultural hazards, which hops or orchards were going all the way out to the corner, which were obstructing views for line of sight. We had WAP to irrigation issues. We had steep corners, sharp corners, steep grades, which did not follow federal regulations. And tribes are supposed to follow federal regulations. Next slide. So on the human behavior side, like anywhere else in the world, you have people who are distracted driving because they're on their cell phones, they're driving under the influence of alcohol and or drugs. They're using other electronic devices like listening to their music, they're not wearing seat belts, and of course, speeding. Next slide. So in our area, we have some major weather prevailing issues. Not only do we have summertime smoke issues due to wildland fire, but we also have fog issues in the fall and winter time. We have poor road service conditions because our roads were built in the 60s and 70s. They're not built to today's standards. Next slide. So we also have behavioral issues where we have people crossing roads where there's no sidewalks, there's no crosswalks, because it just does not accommodate pedestrians. And so pedestrians just will cross wherever they want to. And this is a typical slide of what happens every day in Toppenish. Next slide. We also have issues of trying to get from point A to point B. And this is an elderly grandma who's walking along Highway 97. She's walking northbound on the southbound lanes. And you can see behind her where the guardrails are pushing her out further into the lane of traffic. But that's because she's crossing over what we call a WAP to irrigation drain and culvert. And so it pushes her out further into traffic. And so one of the things that we're looking at is accommodating these issues by creating a bridge for pedestrians. Next slide. This is a typical situation in Yakima Nation where you have overgrowth and signs are being obstructed from the points of view, and you can't see that there's actually a head start about 50 yards in front of you. Next slide. So all of these challenges, they are not limited to just Yakima Nation. These are typical challenges throughout tribal nations. And one of the things that we're trying to do is address these issues on a more comprehensible level so that if the Star Lab or UW goes work with other tribes, they are accommodating to these typical issues in Native American country. Next slide. And so one of the things that we're doing with this is that we're trying to collect data, we're trying to make it consistent, and we're trying to build a comprehensive system that will accommodate all tribes, not just Yakama Nation. And so we're trying to address all of our challenges within Yakama Nation to build a better system so that we can fill in these gaps and these holes where we have data holes. And this is something that we're continually trying to work on with University of Washington and the STAR Lab.
Great, thank you, Hollyanna. I will take over from here, and I'll begin by discussing a little bit about some of the data that we actually used for this project. So we have a lot of different sources that we've collected data from. First and foremost, we obviously want to collect data from our local partners in Yakama Nation. So we set up a weekly collaborative meeting with Hollyanna, as well as we did many rounds of outreach to different tribal agencies to collect and understand some of the local data and local context that we were seeing for this project. Along with that, we utilized data in UW Star Lab's homegrown DriveNet, which is a data visualization platform. Additionally, we used data from the Washington State Department of Transportation, the Highway Safety Information Systems, and OpenStreetMap. So the data we collected can roughly be split into two categories. The first is roadway safety data, which I will cover now, and then the next slide I will cover some of the roadway geometry data that we have. But primarily for our roadway safety data, we have a significant amount of collision data, historical collision data from various agencies and online resources. So you can see the sources listed here, but sort of the four key components of roadway safety data that we have are the collision, we call them subfiles, the collision subfile, which includes information about each different collision that is reported on the roadway. So that includes, for example, number of vehicles, location, time, date, weather conditions as reported by the responding police officer, and other information like that. The vehicle subfile contains information on each individual vehicle that was involved in a collision. And so that includes information that's more specific to the vehicle, such as, make, model, things like that. The occupant subfile does a similar thing for each occupant that is involved in the collision. And then finally, the pedestrian subfile contains information on any pedestrians that are involved in a pedestrian vehicle collision. Oops. All right. And so we also collected a lot of map and roadway geometry data. This data is useful for two reasons. The first is this allows us to visualize where the collisions are on a real map, but also it allows us to understand kind of what geometry conditions may be related to different collisions. And so we can use that. You'll see a little later on in our methods how that can be applied to understand and predict some of the collision rates throughout the area. But these files contain most of the information you would expect, where the roadways physically are, as well as many of the characteristics such as shoulder, roadway lighting, and other information like that. So we conducted several types of analyses on this data to understand what are some of the prevailing causes for all of these collisions, to show kind of what characteristics are most important in terms of addressing the safety concerns that we've seen in Yakama Nation. So the first set of analysis we ran was a machine learning random forest analysis. And so this analysis essentially from 21 different explanatory variables, and you have half listed here, and here's the other half. From these variables, we are trying to use the machine learning algorithm to predict which of these variables plays the most significant role in determining collisions on the roadway. And so we can roughly split these variables into sort of these key areas here, and that includes roadway geometrics, vehicle characteristics, traffic characteristics, driver characteristics, temporal features, crash information, and then finally environmental conditions. And so from all that, we generated a model, which I think is quite intuitive, but we found that the three most critical variables for predicting collisions, as well as specifically fatal collisions, was A, the shoulder width of the roadway, B, the speed limit as a proxy for travel speed, and then C, also the lighting condition. So if there are street lights, then there are much less likely to be a collision, especially at night. The other thing I want to mention is that the right shoulder width did also correlate, was very highly correlated with the left shoulder width. So it actually represents both the left and right shoulder width. And an attendee just asked if a research paper is being published as part of this project. Yes, we have actually already published a paper with the information on this model in last year's TRB conference record. So you can look that up there. Oops, there we go. Beyond just the machine learning model, though, we also developed a segment-based safety index. So from this, this uses a regression model that does somewhat similar function, although just slightly reduced in complexity due to the limitations of regression-based modeling. But you can see here how we formulated our equation to again basically predict the number of collisions that occurred on each segment based upon some of the given roadway characteristics of each segment. So now we're getting to the outcomes of some of these research efforts, which is we created a safety data tool, a web-based safety data tool, where we were able to visualize a lot of the safety metrics that we developed, as well as developing several analytical functions as well to better understand what is actually happening relating to safety in Yakama Nation. So the first function that we developed is a simple point-based crash visualization. So what this does is this visualizes every collision that occurs on the roadways throughout the region. And so each of these circles here represents, with the number inside, represents the number of collisions that happen in that particular area. But as you zoom in, those circles will break up into smaller and smaller circles until eventually you'll have each individual collision there that you can then click on and find information about. So for example, if one were to want to look at collisions at a certain intersection, you could use this function to zoom in and find all of the collisions that occurred at a specific intersection. And then from that, select those collisions and find specific information relating to those collisions. Additionally, we have our segment-based crash visualization, which does a similar thing, except it visualizes these on a segment by segment level. And so this is, again, very helpful as sort of a different way to understand where collisions are happening, and to gather information related more to the segment on which certain collisions are happening as opposed to individual collisions themselves. We also have more aggregate area-based crash visualizations. We have aggregated our data for this function based upon the zip code of the area. And so you can see all of the different zip codes outlined here. And then from that, we can, for each zip code, we can then record the number of collisions. And again, that is very helpful for certain functions and different kinds of analyses when conducting safety analyses. Additionally, for each zip code as well, we can compute the highest intersection-based crash intersection-based collisions, because through our work with the Yakama Nation, we identified intersection collisions as one of the most pressing safety issues for the region. So that was something we really wanted to address specifically with this safety data tool. So this function is sort of the outcome of that, where we can then identify the most important intersections to understand exactly both the conditions of the intersections, which might be related to those collisions, as well as just actually being able to systematically pinpoint where those are. All right, someone in the chat asked if what software is used to create these maps and functions. Wei, I think you're most suited to answer that. Would you mind jumping in and answering?
Yeah, so thank you for the question. So I think the software used for the maps, we use the OpenStreetMap, and some of the software we used our previous, the DriveNet we have been developing in our lab. So, but mostly for the open source tool, we use the OpenStreetMap.
Great, thanks. We also have a question in the chat asking, did we have problems with collision location coding accuracy to related collisions with geometric characteristics? So the answer to that is both yes and no. We certainly have had several issues in the past with collision accuracy, but for this project, most of our collisions are coming from the state DOT WSDOT, as well as the HSIS data set. And so those data sets have already been cleaned somewhat. So while we definitely did have to do more data cleaning to be able to accurately geolocate those based upon the GIS information, we didn't have to go through a full locationing process, which we have had to do for some other projects where we've worked with other partners in the state. Yes, Hollyanna?
Yeah, the other thing that tribes need to know is that we did have issues with trying to get tribal data that filled in these gaps. So yes, we still have holes, but we are working on cleaning that up and making sure that we get all of the tribal data as well. And so if you're coming from a tribe, one thing that you need to address right from the beginning is getting that permission for tribal data. So just that's a side note for tribes.
Yeah, thank you. That is a very important sort of piece to the data quality as well. All right. So beyond just sort of basing our visualizations off of individual either pieces of infrastructure or specific collisions, we also have created this crash heat map, which is I think, a very intuitive way to visualize what areas of the community have the highest concentration of crashes. So you can see here that there's sort of, in this portion of the map, there's two main hotspots for collisions. And so the first is, you can see here right through kind of the heart of the Yakima Nation Reservation, between Toppenish is right about there, and Wapato, the next largest town, is there, as well as the city of Yakima, which is actually outside of the reservation but very near, are sort of the two hotspots for collisions. And then as you zoom in and out, the heat map will adjust based upon the size of your screen. So that's, I think, a very intuitive way to visualize sort of the key areas where collisions are happening the most. And now we're getting a bit more into some of the analytical functions that we developed for this project. So the first is a safety performance regression. And so this uses the regression function that I mentioned earlier. And so this function essentially takes all of the roadway segments that the that are in our database, and this predicts the number of collisions that will occur at each location based upon the roadway geometrics and other prevailing conditions of each segment. And so this is a very, very powerful tool, because this allows us to see which segments are most likely to have a lot of collisions, not just which segments did. And so you'll notice that this map is actually has some distinct differences, especially compared to the segment-based analysis or visualization, which I showed a few slides back. And so this gives, I think, a more accurate understanding of where collisions are actually potentially going to more likely to occur. And so that is a key distinction between sort of the visualization and analytical functions, but it also kind of shows how these two functions can kind of work together, so that you can both visualize where collisions have actually happened and see where collisions are most likely to happen. And combining that together creates a very powerful tool set for understanding the safety considerations of the area. Robert mentions in this performance regression, does it show mainly state and federal highways because that is what is in the map, or is that because those have the highest safety risk? I think the answer to that is primarily an issue with data, as opposed to those roads having inherently higher risk. Because as Hollyanna mentioned, there are still gaps in our data set. We have still been working to get some of the local collision information for the tribal region. So because of that, some of the more local roadways, we just don't have the collision information for that network, and therefore we can't do any kind of analysis based upon that network. So I think that's kind of the key reason why some local roads aren't shown in this analysis. All right. Finally, we also have a data download feature. So this allows our end users to take all of the information that is stored in this web-based platform. We can download all that information into an Excel or CSV file, which is very helpful because now practitioners can then use some of the visualization and the built-in analysis functions and pinpoints potentially certain subsets of data that they want, and then can download that to do further, more specific analysis based upon some of those considerations that can be found in the functions in the data set. So that is the primary function of this tool. And you can see here in sort of the bottom left, there's a downloaded file based upon the information that can be selected through these different windows here. And then finally, somewhat related to that is we also can generate summary reports. This is very useful for a very quick and simple analysis of the collisions that are occurring. And this is also very helpful because this will create standard reporting functions that allows practitioners to kind of compare different areas, but also to compare over time, because as in the future, when more data gets added into this function, it will allow the function to become more robust because that will automatically update both the visualization and the analytical functions that we've developed. But also, then we can see how through this function, we can see kind of how those collision rates and different simple collision factors have changed over time. And so that is a very helpful tool for a kind of quick and dirty way to see what the different roadway statistics are and how they change over time. All right, looks like we have one more question. The predictive map has a level of safety metric. Did we develop that for this analysis, or was that taken from another source? And is that metric based on crash rates? So that metric that you're discussing, that is based on what I showed earlier. Let me get back to the slide. Next one. This one. So this is based on the segment-based safety index that we showed here. So this is our own regression-based model, which models the rate of collision for each roadway segment. So to answer your question directly, we did develop this model, and this is based on the crash rate for each segment.
Yeah. Also, I can add on that for that. So basically, we modified the model based on the HSL model, and also we validated the model, the parameters using our data set. Yeah.
Sorry, I was just muted there. So for the next question, how difficult is it to connect these data analysis tools to other MIM UCC compliant crash databases? I think, Wei, you're most suited to answer that question.
Yeah, I think for connecting the database is not very hard. It's just we need to know the format. Yeah, and maybe we can create an API for that purpose.
The other thing I'd like to add to that is Northwest Portland Area Indian Health Board achieves that goal and goes beyond. They even go into the zip code where the person was born, to where the zip code where they lived when they passed away. And so some of our data exceeds the MMUCC compliant databases. But on the other hand, our tribal data does not meet that standard. And so that's what we're trying to bring the tribal police up to, is to meet that standard. And that's one of our challenges, is because not all tribes meet that standard. And so if you're working with a tribe, you need to make sure that your crash data meets the MMUCC data compliance, so that your data will be compliant with other databases. And that's one of the things that our challenges are right now, is we're trying to get our tribal police department to meet that standard.
Yes, thank you. We also have one more question, which is actually an excellent segue into the next portion of our presentation. So the question is, I assume this tool is open source. How easy is it to replicate set up by other users and researchers? So the answer to that question is yes, it is open source. And actually, this next slide, Wei will discuss some of the ways that this tool can be accessed through GitHub.
Thank you, Sam. So actually, I'm experiencing some of the issues with Zoom. Seems like I'm being freezing from time to time. So bear with me, Sam. So basically, if I have some issues with seeing the slides. So actually, for that question, so basically, one of our accomplishment of this project is to develop this safety data portal for Yakima Nation. And as Sam just showed you the functions of the portal. And also another thing is, another objective of this project is basically to be able to replicate this tool in other places that have similar traffic safety issues. So to answer that question, so basically the tool is open source. We have stored the files and also the datasets we've been using for the tool in the GitHub repository. You can actually follow the README in the GitHub to be able to set up the tool yourself. Next slide, please. Okay, so we have participated and presented several times at the Yakima Nation Traffic Safety Committee meetings about our progress of this project and some of the other projects we have been working with Yakima Nation. Actually, through the presentations, we have gained a lot of feedback and also suggestions and also incredible support from the committee. So our team were invited to give a speech at the 2021 National Transportation in Indian Country Conference. So basically, we are also invited to several other talks like the 2021 HSRS annual Alliance meeting as well. Actually, we have presented our research. I see a question about the research results of this project. We have gave a presentation at the 2022 TRB annual meeting. And also we have actually a speaker session as well about our project. Next slide, please. So we have actually experienced some of the challenges last year when we just started the project, basically with COVID and everything. So I would say COVID hit Yakima Nation particularly hard. And we actually really appreciate USDOT, particularly Paul and his colleagues for being very understanding and give us the extension. So actually, I would say the most important lesson we learned from this is to keep close communication, which actually help us a lot getting through this hard time. So basically, we have frequent email communication with the DNR engineering team, as well as routine Zoom meeting setup throughout the entire project. We have also gave quarterly updates to the Yakima Nation Traffic Safety Committee that actually help us to accomplish the objective of developing the safety tool, especially in the functions that need to be tailored to the specific needs of the DNR engineering team. Next slide. So I would say the most important accomplishment of this project is not actually the development of the tool, but also through the entire process, we have a better understanding of some of the challenges that Yakima Nation are facing. That's also very common for other tribal and rural communities. So basically, we have experienced challenges in getting some of the data sets, as Hollyanna mentioned, which is actually has been an issue that troubling the DNR engineering team for a long time. So because of the mixed jurisdiction in Yakima Nation, the multi-source safety data sets were collected and management by different agencies and oftentimes in different jurisdictions. So this actually introduced a lot of time and efforts for requesting and getting approval and finally getting the data sets. So next slide. So another challenge we're facing is basically there's a lack of data of any kind, especially in the local roads. It's mostly because of the lack of funding and particular infrastructure support for deploying the data collection equipment in the low volume rural roads. So we're just talking about the basic traffic and safety data here. And also there are other like specific data collection needs like agricultural vehicles or some of the environmental conditions that we have mentioned at the start of this presentation, the snow or ice condition on the roadway, the heavy fog, smoke or fire. Those are actually the very common issues that traffic safety issues that need the data need to be collected. That's actually beyond the technologies are deployed in the rural area. So some of the future work basically, oh, next slide, please. Yeah. So for the safety data tool, this safety data tool will serve as the multi-source data management platform. And Yakima Nation DR engineering team will continue adding new data sources, new data sets to this platform. And the Starlab will provide the technical assistance to the engineers and planners. And also the Starlab is actually hosting a in-person training workshop in May for Yakima Nation DNR engineering team. The training will mostly cover the traffic data collection and management technologies and tools, including the safety data portal we have developed for Yakima Nation, as well as other data collection equipment that we want to deploy in Yakima Nation through other projects. So next slide. So basically this, for the challenge of lack of data, especially a lack of a cost-effective way to collect data. So basically we have developed this data collection equipment. It's actually very easy to install and deploy. The good thing about this tool is basically it does not require the infrastructure support like high bandwidth network connection. So the tool can, the technology can collect the multi-model data sources and also communicate with the engineering team. And also it can make analysis on the spot within the device without the need to transfer data back to the server. So basically it does not require, have a high requirement on the technology personnel to maintain the tool. So basically we want to deploy this technologies in Yakima Nation for data collection and also adding the data sets we collected from this device to our safety data portal. Yeah. Thank you.
All right. Thank you, Hollyanna. Thank you, Sam, and thank you, Wei. That was great. Also, Sam, great job moderating the questions throughout the presentation. We do have a few more, and Wei, you may have touched on this, but this might be a good question for Hollyanna to weigh in on a little bit. So the first question is Yakima Nation planning to use this tool and its outputs to support and enhance an application for federal funding to improve roadway safety characteristics at its hotspots?
Yes, we have total intention of continuing our work with the UW Star Lab and with the projects that we are trying to continue working on, because, you know, unfortunately, being the #1 deadly county in Washington State is not something that anybody wants to brag about. But, you know, we do have the highest number of fatalities for crashes and for pedestrians. And so this has been a very intense subject for me because being a former police officer, being a former paramedic, having some of my own family members being the victims to these situations, it's very close to my heart. And so if we can implement this program here at Yakima Nation, and we could do this for other tribes, I mean, imagine what we can do. You know, maybe I wouldn't have lost my brother. And that's my push, is because so many of these people we know grew up with them, went to school with them, being family members. It's not about just making a difference. It's about saving your own family and saving your own people. And so this is very personal for me. You know, I almost lost my own life to a motor vehicle crash when I got hit by a drunk driver. I almost lost my parents. I almost lost my brother. I've had so many family members who've had close calls to intersection crashes or DUI crashes, that this isn't just about me. This is about family. This is about our people. This is very personal, because when you live in a rural community, you know everybody. And even if you're not friends with them, you still know who their family is. And, you know, I've had so many classmates that I've lost to motor vehicle crashes or pedestrian fatalities. It's work that means more than something than just work. And that's why I'm loving working with UW, working with Star Lab, working with PacTrans, working with CSET, working with Sam and Wei and Yinhai. I mean, we're making a difference a little bit at a time, but you can only take one step at a time, and that's what we're doing. We're taking one step at a time, and we're making a positive difference. And I think that's the most important thing you can say in Indian country, is when you're making that positive step forward, you're making a huge difference, even if it's a small step.
Thanks, Hollyanna.
Thank you, Hollyanna.
So this next question is kind of about future work. And Hollyanna, you just mentioned that we're taking this first step. So maybe let's look forward a little bit. So we're kind of established and we're working through the first step. So maybe, and I'm not sure who would be the best to touch on this, but kind of what does the future work look like, and how does it relate to the work that's already been done?
Yeah, I can jump in on this one. So I absolutely agree. I think you framed that question very well, Cole, and kind of what the future, sort of the next step after this first step, will look like. So the key next step that we're looking at is diversifying the data sets that are available and collected for Yakama Nation. So this safety data visualization tool is only as good as the data that the actual safety related data that we can put into it. And right now, earlier in the presentation, we talked about what some of those current data sources are. But of course, there are so many more aspects of safety that we want to include in these analyses, because it seems pretty intuitive that just the information such as, you know, roadway geometrics and the collision data is not all of the factors that influence collisions and safety concerns. So for future work, what we are going to do is we're going to deploy sensors actually to measure specific data points that we need to better understand the safety issues that are present in the community. And so we're doing this, there's a picture of the sensor we're using here up on the right. And this sensor basically will allow us to have a richer set of data, which will then when incorporated into this visualization and analytics tool, it will allow us to have an even better understanding of the safety issues that are affecting the community.
Great, thanks, Dan. And just a reminder, we have about 5 minutes left. If you have questions, we've been getting a steady flow of them in the Q&A box, but we have a few more minutes if anyone else has questions. I am going to read one. Way I saw you answered it via typing, but because it kind of builds on what Sam was just talking about, I figured I would ask it verbally. So you mentioned data will be collected using this cost-effective device. So the first question is, this data will be video data, correct? And then the question asker is interested in kind of how the raw video data will then get kind of put into a spreadsheet format to be visualized.
Yeah, so as I type in the chat box, basically the device collects primarily video data, but they also have other sensors integrated in the device, like the environmental conditions, temperature, humidity, those kind of data also collected. For video data, we have the option to not transfer any video images back to the server. So basically the device can analyze the video or images, extract information like traffic by road user type or roadway conditions, like there's snow or ice covered in the roadway, or different kind of events. They were collected, and those kind of information can be transferred to like the traffic managers or the road users directly through the mobile app we developed.
Great, thanks, Wei. The next question, so someone's saying they're having a hard time finding the TRB report that you mentioned that explores the factors that predict pedestrian fatalities. If any of you have that, perhaps you could just, you could hit type answer and type that so that people can go and look at the answered questions and get that title. That might be most helpful there.
Yeah, I can look that up. So why don't we go to the next question while I go find the title for that?
Yep, that sounds perfect. The next one is, are the findings and tool directly transferable for use by other tribes? So you mentioned that a lot of this is already on GitHub and you have a lot of the data sets there. Do you feel like this is all directly transferable, or does it require some maybe situational modification for other tribes?
I think there's going to be some situational when it comes to other tribes, because no tribe is the same. We all have different types of government. We all have different types of protocols and laws when it comes to data. But for the most part, we're trying to create a system that is easily transferable to other tribes and can accommodate those uniquenesses to each and every other tribe. Because one of the things that when I started working with Sam and Wei was, and Dr. Yinhai, was letting them know that no tribe is the same, but we have similar protocols. And so we're trying to create a system that if a tribe wants to adopt this system, they can easily accommodate for their unique system, whatever that may be.
Great, thank you. This next question, the Yakima Valley Conference of Governments is currently updating the travel demand model that has travel demand on most major roadways in the area. They also have a streetlight data license, which is now updated with the 2020 census, that can be used to extract demographics of users of the higher risk roads shown in one of the graphics. We have also integrated the WSDOT crash history data into the travel demand model for further analysis. Please feel free to contact me at Yakima Valley Conference of Governments. That's from Robert Schull. Thanks, Robert. And we are basically out of time. So unless I get any more last minute questions pop up. Sorry, we have one more that just popped up. If I understand correctly, the future work video data will be at hotspot locations. Are you also scanning the entire system to document assets and risk factors to identify higher risk segments?
Yeah, I can go ahead and jump in quickly on that. Yes, we are only going to be initially deploying the sensors at, as you say, hotspot locations. We did, as we mentioned earlier, we identified intersections as being one of the key areas where collisions occur, hence the intersection visualization function. So essentially what we will be doing is our initial deployment will be there because we do, unfortunately, as with everyone, we have limited budget, so we can't deploy sensors everywhere. But we are currently in the process of selecting the final locations for these sensor deployments based upon which intersections are the highest priority and that have the where we have the ability to install the sensors. And so to sort of that answers the first part, and then for the second part, if we are scanning the system to assess the risk factors. So yes, we are doing this in a very conscious way to really pinpoint the areas in the community where the risk is highest for these installations. So it's sort of related to what I was just talking about. We are selecting these intersections based upon the highest risk as sort of our key constraint.
Yeah, so we'll start with several locations as Sam mentioned, but we will keep looking for fundings for deploying more sensors. Yeah.
Yeah, and one of the things is that we're always updating our data, even though we don't have official data. But when you live in rural America, you hear about car accidents at this place, at this place, at this place. And so we kind of keep a mental note of what is trending. And so we have a list of our 15 most dangerous intersections within the reservation boundary, but we're also kind of keeping a mental note about what's happening in the news, what's happening in real time, and keeping an eye on those hot spots that are trending. And so, you know, you just have to accommodate for data when it comes to real time. You can't just rely on the data itself. You have to sometimes just rely on what's happening around you.
Yeah, great. And I think that that's a good place to stop for today. We're at time. So one last note, I mentioned this at the beginning for those of you who didn't join right at the beginning. This session has been recording. And we will get that edited and up on the PacTrans YouTube channel and shared through our website and e-newsletter in the days to come. If you're having a hard time finding it or you'd like me to specifically send you the link to it once it's posted, you can email us at pactrans@uw.edu and I'll make sure you get a link to it. With that, I would like to thank again Hollyanna, Wei, and Sam for their time and excellent presentation today and all the hard work they've done. I hope you guys have seen in the chat there have been a number of thanks. And we're all hoping that this serves as a great model for how these things can, these kinds of partnerships can make a real lasting impact in the future. So thank you. And thanks everyone for joining today. Have a great day.
Thank you.
Thank you. Take care.
Thanks, everyone.